Hello, ladies and gentlemen. Today we are going to take a look at distance and midpoint. We're going to look for some formula creation here today. So we're going to find out ways to find both of these on a coordinate plane. So you're going to need your notes, which include a foldable from me where you can write those things today, as well as something to write with and a calculator. Because we are working with numerical values today, it might be nice to check some of your calculations. So your foldable notes look like this. They were basically a half a sheet of paper that I need you to fold upwards, as you can see here, kind of folded up so that the outside looks like this. So we have distance formula flap and we have a midpoint formula flap. So we're going to be working with these formulas here today and using them to find distance and midpoint on a coordinate plane. Now, finding distance on a coordinate plane, don't write this part down, but finding that distance is pretty simple when we can count these lovely squares, right? The whole idea of graphs is that they're nice, they're scaled. So you can tell how far it is from here to here based on the idea that you can count those boxes. So I can count easily that this is 6 units across, and this is 3 units down, and 6 units across, and 3 units across. So I could easily answer questions like how long is it from A to B and what's the distance from B to C. It becomes a little bit more complicated when I need to find the distance from A to C. Now A to C happens to be this diagonal here. Now we can't really count the boxes because they aren't following the 1 unit. For example, this is 1 unit here. This is not 1 unit. I don't know how much that is. We would need to find a way to calculate that. Now, one way you use to calculate distance diagonally here would be to maybe view this as a right triangle, right? You could view this as a right triangle, and you could say, hey, I know a formula that might help me find this distance. 3 squared plus 6 squared equals x squared. What formula am I using? That's right, the Pythagorean theorem. A squared plus b squared equals c squared. C is always that hypotenuse. And you could see I'd have a 90-degree corner right here, and I could go ahead and calculate that. 9 plus 36 equals x squared. When I add those two together, I get the square root of 45, and then I could go ahead and simplify this. Square root of 9 times square root of 5, 3 square roots of 5 would be my distance from A to C. So there's no way I was going to ever count those boxes to find that, but I could use the Pythagorean theorem if I want to. Now what happened was, well, Pythagorean theorem is nice when you have graph paper, for example, or when it's easy to just draw it out. But when these numbers or these coordinates get so large, like you're finding the distance from 241, 291, 300 and 417, I mean, whatever it might be, it's a little bit tougher to draw those out, right? So we created a formula based on the idea of that Pythagorean theorem. Check this out. If I were to make this be the right triangle, similar to what we saw in that picture, notice I don't actually have any numbers here, but I'm just going to leave them as the letters. The x1, y1 representing the points from my first, or the coordinates from my first point, and b representing the coordinates from my second point, the x and then the y. How would I find out a measurement for length here along this part of my triangle? Well, for ease, I guess I would just find out how far it is from here to here, right? Well, if I don't have any actual numbers, what would I do to figure that out? I would just subtract these x coordinates. This is the x coordinate of this point. This represents the the x coordinate from the second point. So we would go ahead and just subtract those. So we might take x2 minus x1 to figure out how far this length is. Now what about this length? Well, we would go ahead and subtract the y coordinates. Y coordinates go up and down. So we'd say how far is it from y2 up to y1? So we would subtract those to find that difference. It's kind of a funny y. There we go. So then when I'd go ahead and I'd want to calculate this out to try to find this distance, I could use the Pythagorean theorem. I'd say something like a squared plus b squared equals c squared again. Now notice the side lengths on my triangle here are now these funny formulas. Well, no big deal. I guess I'd just plug those in. This would be my a squared, and this thing might be my b squared. And then my c, my hypotenuse, would be the distance I'm trying to find, squared. So if I'm trying to find distance now, the d needs to be alone. To get rid of a squared, I would just square root the whole thing. Check this out. So the distance equals the square root of the x coordinates subtracted and then squared plus the y coordinates subtracted and then squared. Using the Pythagorean theorem, that's how this formula came about. People tried to find shortcuts, especially when those numbers became so crazy to graph. Hence the distance formula you see written on your foldable now. So we need to go ahead and figure out a way to calculate the distance between sets of points. You already have this distance formula on here. Please make note somewhere on there that x1, y1 and x2, y2 are coordinates from your ordered pairs. They just represent the coordinates or the values or the numerical values from the set of points. So let's go ahead and do a couple examples here. We want to find the distance between 4, -6, and 0, 3. So we could whip out a piece of graph paper and go ahead and do the Pythagorean theorem if we wanted to. Nothing wrong with that. Or we can use that distance formula, which is based on that anyway. So distance equals the square root of, now remember, this is my first point, x1, y1. This is my second point, x2, y2. And I'm just going to go ahead and plug them into the formula. So the formula has some parentheses here and a squaring. It starts with x2 minus x1, y2 minus y1, and we'll go ahead and plug those values in. So x2 is 0, minus x1 was a 4. Plus, now we'll go ahead and get the y from the second point, 3, minus y from the first point, -6 squared. So if I go ahead and calculate some of those numbers in here, this guy right here, 0 minus 4 is -4 squared, plus, now negative and a minus sign here would become a plus, so we'd have 9 squared, and now -4 squared is 16, 9 squared is 81, so we get the distance, or that calculation there, when we add those two together, we just want to add them up, don't take the square root yet. We want to take 16 plus 81 and get that value, and then don't take the square root. We'd end up with the square root of 97. Now, can that square root of 97 be simplified at all? Can we break it apart? Can we find a perfect square that divides out of there, like 4 or 16 or 25? That's what we're trying to decide when we break these apart. Can we do that with this number? And the answer is no. So I would leave him as the distance equals the square root of 97. Let's go ahead and try the second example. We're going to do the same thing. This time I'm not going to write the formula because we already see it to the side there. Let's just plug in those values. X, Y, X, Y. This is from the first point. This guy is the second point. So we'll just go ahead and plug them in. So we have x2 minus x1, -4 squared, plus y2, -8, minus y1, 2 squared. And now let's go ahead and calculate in those parentheses. 0 minus -4, that's like adding. So I get 4 squared plus -8 minus 2 more is -10 squared. So now to keep going here, I'd have 16 plus 100. Remember, negative numbers squared become positive. So I'd have square root of 116. Now again, you'd want to ask yourself, rather than write the decimal, can we break this apart using a perfect square? Is there a perfect square that divides out of 116? So you might try some in your calculator, 116 divided by 25, 116 divided by 36. And I found that 116 can be divided by 4, and 4 is a perfect square number. So 4 times the square root of 29, square root of 4 times square root of 29, the square root of 4 becomes 2. The square root of 29 stays, so my simplified answer is 2 square roots of 29. So we can go ahead and find that distance just by calculating using that formula. Now let's talk about midpoint. What does it mean to be a midpoint? A midpoint is the point in the middle of a segment that divides it into two equal parts. So in other ways to think about median or middle or midpoint, all of those kind of bring together this middle notion. Median, mean, we're trying to find the middle. Let's say I wanted to find the average or the mean middle for some test scores. If I have an 89 and a 96 on two tests and I want to find the average, what would I do? Well, I would just add them together and divide by 2, right? Because that's how many I have. I have two tests. I'd add those two together, find the sum, and divide by 2. We're going to do a similar thing with the midpoint. The midpoint is us finding, I'm going to put an equal sign right here. Let's put an equal sign on the foldable there. The median or the midpoint or the mean, the middle equals x1 plus x2 divided by 2, y1 plus y2 divided by 2. So to find a point, we're finding an x, y spot on a graph right here. And to find that spot, we would just take the average of those 2 points. So we're just going to find the average of them. Now when you add 2 points together, you add the x's and you add the y's and you divide it by 2. That's where that formula comes from. So let's look at a couple examples of this one and then we should be good. Find the midpoint of the line segment with the endpoints 1, -2, and -2, 7. So we need to find the midpoint. So the midpoint equals x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we're going to add the x's, divide them by 2, add the y's, divide them by 2, and you'd have the midpoint. So xy again, just like before with distance, x from the first point is 1, plus x from the second point is -2 over 2. Y from the first point, -2, plus y from the second point, 7 over 2. So if I simplify this, 1 plus -2 is -1 over 2. -2 plus 7 is 5 over 2. And if you like those as decimal values, we'd have -0.5 or -1/2, and 5 over 2 is 2.5. Okay, that's where the midpoint would be on that graph. Let's do one more. Plugging in those values a little bit faster this time. We're going to have fractions, adding the x's, adding the y's, dividing them by 2. So x from the first point plus x from the second point. -4 plus -2. Y from the first point, -4 plus y from the second point, -8. -4 plus -2 is -6 over 2. -4 plus -8 is -12 over 2. And now if we simplify, that would be -3. -12 divided by 2 is -6. So that represents the midpoint on that graph. All right, so we can use the midpoint and distance formulas to find both the distance as well as a midpoint. We're going to continue to practice this in class, and I want to thank you for taking good notes.